And here I just wanted to share some knowledge that I got in the past years about like AI. Here especially I want to talk about things such as reason, history, gap applications, what we can and cannot do with AI. Of course. That's my kid. It may be a little bit weird to start a presentation with the song, right? It's even not in English. Do you guys know what's the reason for that? That's actually my Valentine's gift for my wife this year. And the reason is that it's created using AI. So I wrote the lyrics and then asked the AI to compose the song for me. That's how it works. So I just want to use this little example to show you, what we can do with AI these days. So again, we'll first take a look why I look into AI, what is AI, history of AI, and especially because we are in engineering, so we want to have a good connection between, what people do, in the AI area and what we learned from our class, especially for traditional engineering practice. I want to bridge that gap. And also talk a little bit about AI applications, and at the end, also share some of my experience about what we can and cannot do with AI. So I just shared that one little example. Actually, that story continues. So I try to upload that song to like a public music share platform. They said that you need to prove, you created this song. And you need to show me like 30-second video showing that you are singing the song without the background music. Because the AI created that song, so that's not my voice. And I try to use like another AI tool, try to say, hey, do that for me. That's what it looks like. And if you observe closely, you will find that this is not good at all, right? Especially if you look at the teeth. And then eventually I go with another tool, try to make it look a little bit more real. This time it works better. So this is what we can do with AI these days. It's pretty cool, right? So before we share more content, I first want to take a look at the definition of AI so that all of us can be on the same track. My understanding of AI is like we can understand it as a method. So a method of making a computer control a robot or a software think intelligently like a human mind. And usually this is done by mimicking what our brain, our neurons can work. For example, if any of you have ever taken any courses from neuroscience, you would know that how they work. Neurons use electricity and chemicals to transmit signals, and usually for different types of diseases or different types of movements, different patterns for those signal transmission will be generated. So here in AI world, we are trying to reproduce that, the biological intelligence, to create artificial intelligence. And because of that, usually we need to figure out how the neuron works and also how to understand the cognitive process. And the outcomes of all of these, these fancy AI applications, they're actually just intelligent software or systems. When we say systems, it maybe we have both software and hardware. And in fact, all of us may need to pay attention to is that because the AI has been worked on by people from different areas, including engineering, and because of that, people have different ideas, have different histories, so they may use different terms to describe the same thing, or may use the same term to describe different things. So if you have ever done or ever learn anything about AI, you would know that, for example, for data, single individual data points, we have concepts like, for example, instances, examples, samples, data points, right? And we also have like attributes, like dimensions. All of those things may refer to the same thing, but they may all mean totally different things in different contexts. And because of that, there's a lot of inconsistency, and that also can give people a learning difficulties, especially for us. We're in engineering, we're not familiar with that topic. And for example, some of my students took classes, for example, machine learning classes from computer science. They said that, I did not learn too much. There seems like a big gap there. And that also kind of prevented like engineers from using AI for many like real work that we want to do in engineering. So after the definition of AI, next, I think it would be really helpful to take a look at what the AI covers and what is the big picture for AI. And here, this is my understanding. Because these days, we have a lot of things. We have artificial intelligence, we have machine learning, we have deep learning, right? We have reinforcement learning, we have large language models. So what's the relationship between these different things? And here, this is how we can understand it. So artificial intelligence, that's the big thing. It covers everything that we want to do for AI. And then within the AI, we have two subdomains. We have one called general AI, or these days they call it artificial general AI, or AGI. And the other one is the narrow AI. So the difference between an AGI and narrow AI is that for AGI, we are thinking about creating like one thing, one object, or one like system that can do everything for us. For example, for those human-like robots, we imagine that they can do the homework for us, right? They can take the exam for us, do everything. They can even, do the laundries, do the groceries. That's the AGI. But for narrow AI, that's the AI that actually most of the AI people has been working on. We're not talking about creating something that can do everything. Instead, we're talking about individual things. For example, hey, I got this senior design assignment for this task. I want to analyze the data. So I go somewhere, find some algorithms, get input, output, do the analysis, get a trained model. So in the future, when I get more data, I can do some predictions. That's kind of a narrow AI thing. And then within the narrow AI, we have two subdomains. We have something called symbolic AI. Now people call it good old-fashioned AI because it was very popular in the 1970s, 1980s. These days, people spend more time on the other category called numeric AI. So from their names, symbolic AI, you can see that we're trying to use symbols, trying to do the deduction thing. And for numeric AI, now it's predominated by machine learning. So machine learning, we're trying to play with data. And when we say data, we have symbols and numbers, but eventually we can convert all of them into like numbers, right? So that's why we call it numeric AI. And for numeric AI, what we're trying to do, we're trying to learn the patterns or knowledge in the data. So knowledge say that, hey, when you get something like this, you can get another thing. That's the pattern. And within the machine learning, we have the traditional machine learning. So you possibly have used some of the algorithms or tools before, such as linear models, basically just like curve fitting, right? I think possibly all of you have done that before. You have a few points, click, you can get a straight line that can fit the data. We have decision trees or like random forest. We have support vector machines. We have Bayesian method. We have artificial neural network, ANN. That's the neural networks that we usually talk about. We also have some other well-known algorithms such as K nearest neighbors. And ensemble learning is also very popular these days. And within the traditional AI, this ANN thing got so big. People find that it's so useful. It's more useful than other tools. So people rushed into this area and further develop it. And then we have deep learning. So deep learning is basically the use of deep artificial neural network for doing some learning work. And deep learning, you possibly have heard, for example, convolutional neural networks, CNN, recurrent neural networks, RNN. We'll also have the game, RB, FM, MLP, SOM, autoencoder. Those are different just architectures for deep learning, different structures for the neural networks. And another popular area these days is called reinforcement learning. Reinforcement learning is that let an AI agent, like smart thing or algorithm that we want to train, to play in a real environment. And then that agent can learn how to benefit, how to do a task with the best rewards. For example, several years ago, we have the Alpha. I'm not sure if you guys still remember. We have the AlphaGo, AlphaZero. That's kind of a big victory of AI over human beings in the Go game. And that was done using reinforcement learning. And now many people still use reinforcement learning for control stuff. For example, even for controlling robots. And the robots can go to interact with the people. And in many cases, that's attributed to the use of reinforcement learning. So you can see this is kind of the big picture for AI. And next, a little bit history about AI. Because some of you say, hey, I'm interested in AI. I know that is powerful, but I'm a little bit hesitant. I'm not sure whether I need to do anything about AI. Actually, I think that's a good question. I always have that question, and nobody knows the exact answer to it. So I started working on AI in like 2015, 2014, 2014. Back at that time, deep learning was not well known by at least people outside of academia. And some students approached me in 2017, 2018. They got to know, hey, I think AI will become like a big thing. I want to do something about it. So what do you think the future of AI? I said that I have no idea. I said that I feel that there's an IT bubble there. It can burst anytime, but I don't know when will happen. I feel that, it may happen around 2021, but then we got the ChatGPT thing. Now there's another rush for AI rush due to that. And so nobody knows the answers to that, but I think it's always helpful to take a look at the AI history. That can possibly give us a better idea of what may happen, because some people say that history would never repeat, but it rhymes, right? So you can learn something from it. And now we are in the time, some people call it the third wave or third tide of AI. So that means we're still at the peak. But if we take a look, it go up and down, wave one, second wave, and third wave. And all the AI stuff actually started with like rumors, stories, in which some craftsmen, they created, for example, puppets, and then use some way to give the puppet intelligence, so the puppet can talk with people, can do things for people. That's kind of the rumors that people think, maybe we can create like intelligence some way. And then that's the time before like the 1940s. And then we have the golden age of science fiction between 1938 and 1946. And that also prompted the idea of creating like artificial intelligence. Then we have some real changes in the 1940s. For example, we have the first stored program computer. That's 1949. That kind of gives the hardware foundation for creating AI. And then for example, 1950, we have Turing machine, which kind of set up the theoretical basis for creating AI. So we can see that we have good things happening in both hardware, software, and theories. And we have the first AI computer program in the year of 1955. And then the year of 1956, this is a very significant time. Many people believe that the more the AI was born in this year, a group of AI researchers, they gathered at the Dartmouth College, and they had the first AI conference. And after that, we started the first uprise of the AI wave. And the many governments, such as, for example, DARPA, back at that time, actually it's not called DARPA, they distributed a lot of research funding for doing AI research, and the people was really optimistic about development of future of AI. Many people believe that AGI, so I talk about robot thing, can be achieved within one generation. Some say that maybe within like 3 to 8 years. That was in the 50s. People believe that it can happen that soon. But obviously, it did not happen. And because of that, people lost hope in AI, so they kind of withdraw the research funding. Then, around the year of 1974, one researcher published one book, and in that book, that researcher proved that artificial neural network at that time, 2-layer, 3-layer, ANN, can only do extremely simple linear work. It cannot even analyze like a problem with like a minor linearity. And because of that, people believe that, oh, this is just a toys, and that's kind of shut down the whole research about neural networks for about 10 years. We have a first winter between 1974 and 1980. Then around 1980, we have a new type of AI application called expert systems, got very popular in industry. Many companies that believe that, no, now we have a company, we need to have expert systems so we can store our own institutional knowledge. And because of that, so many industry money was put into this area. And then in the year of 1987, we have the economic bubble first in that year. And also because many AI plans actually did not deliver what it is supposed to deliver. So that also discouraged many people. So we entered the second AI winter. That lasted from the year of 1987 to year 1993. And then we entered a very slow recovery phase because we already have 2 winters. So that kind of discouraged a lot of people. And in the third recovery stage, people don't want to talk about AI anymore. Even many people are doing something relevant to AI, so they're trying to get rid of all the work that with the AI tattoo. They try to give it a different name. So they try to do individual works in individual areas which are relevant to AI, contribute to AI, but not under the name of AI. And the thing keep going all the way can deal like early 2000s. For example, one major achievement is one. Many people believe he is the father of modern deep learning. So that guy published one paper in Nature, and that kind of sparked some interest and also encouraged the people to look into that area. Then in the year of 2012, that's a very significant year. One guy, he used deep learning. There used to be like a computer vision competition. For example, they have different images, photos with different types of objects, cats, dogs, and they want to use like computer vision algorithms, AI algorithms to classify different images automatically. So that's a competition. Everybody can come up with an algorithm to do that to see what score you will get. And that guy used the convolutional neural network, which is a type of deep learning architecture, and surprised everybody. It seems that it can achieve the performance that's way much better than the traditional methods. And that's shocked the industry giants, the Microsoft, the Google. So they put a lot of money into this area. And also due to some other things, we can have the third type of AI. In my opinion, there are like 3 of them. Why we can have the third wave of AI? Now, the first one is obviously the development of the algorithm, right? There are new algorithms. You guys can you guys guess what are the 2 other factors that contributed to the development of AI in the third type? First, development of algorithms. Any guesses? What are? Yes.
Better chips.
Yes, there you go. So we need more computing power, right? So better chips. Any other guesses?
Maybe like air conditioning to like cool down machines as you run them. If you can run them faster.
That's also relevant to the computing power, right? Yeah. Good guess. What else? Machine learning uses data, right? So we have data, way much more data than what we had before, right? We have the satellites, we have the surveillance cameras, and we have those low-cost sensors. We have smartphones with a lot of sensors on them. We have this smart and connected vehicles. So we have big data, and that also propelled the development of AI. So these are kind of the 3 major reasons that triggered the third wave of AI. Now we are still in it. Now we're not. Most of the effort have been devoted to large language models. In recent years, we also have AI agents. So you can see that this is the history. What has already happened about AI, but nobody knows, where this curve will end with. It's just keep going up. It may, have a very significant drop this year. So nobody knows. And next, I want to make a connection between what is AI can do and what we can do with our traditional engineering methods. For example, you guys have learned a lot of things from your civil engineering courses about designing things, right? For example, you have structural components, you want to do the analysis, you have equations, you have procedures, you have the criteria. So those kind of the engineering methods. And AI method seems something that's totally different, but we can actually make a very simple connection here. So most of the problems that we are trying to solve in engineering, you actually can boil down to one: mapping. So mapping is a math term. In a simple way, you can understand it as like a mathematical function. So we are trying to find a mapping that can take us from the input X to the output Y. For example, in your design problem, you have your numbers for your loadings, you have your numbers for your material properties, right? You know what's the design guide. You feed all of them into there, and you can generate something. Either like, for example, what is the safety factor, for example, in geotech, and what is the loading factor, what's the ratio, something like that, or what's the probability, and whether that can be accepted for this design guideline. And that's kind of go from X to Y. And AI actually does the same thing. In short, we can understand the difference or connection between AI and the traditional engineering methods, like they can be used to do the same thing. That is to find a mapping to go from X, the inputs, to the output Y. Y, again, could be a design or could be just like some calculation results for the loads, or for the system capacity. And we can also use examples to prove this. So here's a very simple example. For example, if the problem that we are trying to solve is to predict the trajectory of a ball that we throw away from the top of the building, like this. So people can solve this problem in different ways. And if we are talking about the simplest way, in this case, is the analytical way. So based on the knowledge that we got from high school, we know the acceleration, we know the velocity along the X direction, right? There's no acceleration, you will overlook the wind resistance. We have vertical direction, we have the acceleration coming from the gravity, right? So we know the A, we know the initial velocity. So we can use the analytical the theories that we learned from high school to come up with a function between X and Y. Here, X, we want to predict the trajectory, right? That's the X, that's Y. So we can get the trajectory between X and Y at any point. And they are also relevant to time. So we can predict it. That we can solve it using an analytical way. If we want to do it using something like a numerical way, numerical analysis, for example, some of you possibly have done like finite element, finite difference, even something like optimization, solving equations. They may involve some type of numerical analysis. Numerical analysis is that instead of solving the problem in a continuous domain, now we are trying to divide either the time or the space into small slices. So we would have something like time steps or mesh, just like the finite element thing. And to do that, we will use the same equations, but we'll do it step by step. For example, at step 1, now we divide the time into different steps. For example, each time step could be 0.1 second. And at t equals 0, what's the initial velocity along x and y direction? What's the acceleration along x, y direction? And then we move to the next point. At t equals 0.1 second, we repeat the process based on what we know from previous step. And that can be done iteratively, and eventually we will get a trajectory at not every time point, but at all the time steps. That's the numerical way. And the experimental way is that, instead of doing everything using on paper, now we can just go to lab directly, right? just throw a ball and set up cameras or any like object tracking techniques there, and that can help us to get that trajectory. We can do that when we have money, the equipment. And the last way is the data-driven way. That's kind of the machine learning way, the AI way. So for this way, it's just like, hey, one of my classmates just went to the lab and did that experiment. I got a very cool data that get the trajectory of the object, but I don't have the money. So I talked to my classmate, hey, can you just give me like 3 data points? I don't need all of them, just 3 of them. So your classmates give you 3 data points, you come back, and then you say that I believe that the trajectory follows some types of curves. You take a look, actually it's the second order polynomial, right? But I know nothing about it, so I use curve fitting. I try different things. First order polynomial, second order polynomial, keep going and find that, oh, second order polynomial works the best. So in that way, I get 3 points, I do the curve fitting, I get the same thing. So you can see that using different methods, we can get very close results in this case. So that shows the connection. So when you're thinking about, hey, I want to solve this, how should I do it? Now you know that you can go with the traditional engineering methods, or you can do a little bit more, right? So now besides analytical, experimental, numerical, now we have one more option. That's the data-driven method. But there's a big difference between the data-driven, the AI, machine learning methods, and the traditional engineering methods that work in with the different procedures. For example, in the traditional engineering methods, what happens is that we have something called a model. A model could be like, for example, design procedure with equations, with different criteria in it. That's a model. We also have data. Data is something for the specific case. For example, for this building, I want to design. I have some data, right? I know the loading the building needs to sustain. I know the material properties, what type of concrete, steel I want to use. So for example, I have data. I put the data into the model. I can get an answer. The answer could be yes. No, this design is good. I get a design and I know that it's good. But now let's say that we want to use data-driven methods or AI methods. Now we're going to have a different procedure. Now what happened is that, so we use something called a supervised learning as one type of machine learning as an example. What happened is we have answer first. So we need to let the AI know or give the AI some design cases first. In those cases, we have the design and we have the calculation, we have everything, including the input of the material properties, loading. We feed that into the AI, and the AI will try to learn from those existing cases. And by going through that process, which is called a training process, we will get a trained model. And the cool thing about the trained model is that in the future, when we have a new case, which is not necessarily the same as what we did before, we can get the new data when we have new materials and new design expectations. We fit them into the model. The model will give us some new answers. For example, oh, here, this is the design that you can consider. And we tested, it's good. So that's the cool thing about it. So that can save us some time. So you can see that now we have like at least two essential steps instead of one when we are using the AI method. And about AI applications, so we are talking about all the sectors, all the areas. Actually, most of the AI money now has been directed to healthcare and medical diagnosis. And also, there's a lot of AI research applications in marketing, and also self-driving, obviously, that use AI a lot. We also have speech recognition. So everybody uses a smartphone. Now you talk to Siri or any agent. That's pretty much AI. We also have a lot of AI applications in traffic application. But if we go to the engineering sector, especially civil engineering, we also have many AI applications. For example, we have the building information system, BIM. Now we can use like 3D AI-powered method to improve the design of the building. And for data processing, now many AI algorithms can be used to process the data automatically. For example, identify the abnormal data points from what you got from the raw data. So that we don't need to do the tedious work anymore. And we also have very good AI algorithms for detection. When you have a complicated system or you have some designs we can use that to detect whether anything has gone wrong in the process. Obviously, we have prediction. For example, we want to predict what's the weather for the next 7 days. Based on what we have now and the weather history, we can use AI to do that. And we can use AI for management, especially AI-based predictive and analytics through like image processing, risk management, and maintenance. For example, in structural engineering area, now people can use AI, use cameras to detect the cracks on the pavement surface, or go to bridges and then use like some camera to tell what the components, structural components we have there, and what's the health condition of that structural component, whether we have major issues, whether any maintenance operations is needed in the near future, or something like that. We also have discovery and optimization. That's also a big area, for example, in civil engineering materials. Now, in the past, we need to try different things manually to tell us what's the best way to do it. But now, with the AI thing, AI can take some data and then try to learn from data, then do virtual experiments. Say that, hey, maybe that materials can be generated in a better way using AI. That's for material discovery. And also, we have automation, for example, using AI-powered robots to do things for engineering tasks. For example, in geotech, we can use AI to develop like robots that can do the trenching, do the digging job, even do the tunneling job. So that can be done automatically now with AI. AI can tell, what is the condition we have here, and how much force, what's the angle I need to use for my excavation job, and then how that can be optimized to make sure that we can minimize the risk of the construction job and also maximize the economic and the safety benefits. So all of these things, actually, this is just a very short list, and if you keep going, it could be way much longer. And people from different areas, even sub-areas of civil engineering, they're trying to come up with better ideas to do things using AI. So next, I want to talk a little bit about what we can and cannot do with AI. First, I want to talk a little bit about can't. And I think about many courses that you have taken or you are taking. You guys know that you made your syllabus. Sometimes you will see something like this use of AI, right? How you can use generative AI, especially large language models, ChatGPT, to do things. And then actually that raised major concerns, not just in academia, all the areas. We have like bias, we have like ethics, and we have many things we need to pay attention to. Here, I can use one example. So I published one book about AI recently, and for that book, I proposed to use a cover like this. And the reason is that this one was generated using AI. So I think, using an image that was generated using AI for an AI book, that's a very cool idea, and I love this image. So I contact the editor first. Editor said, that's a cool image. I like it as well. So let's use it. And then the office who is in charge of this image copyright thing, they said that, no, you cannot use it. You told us that it's generated using AI. Now the publisher is Springer. Springer said that now, according to our Springer's policy, we cannot use any content generated using generative AI for book covers. Like if it's for like some technical content, you need to justify it. But if it's non-technical, like this one, like a cover, you cannot use it. So I cannot use it. I was really frustrated. We went back and forth for the whole publication process, and possibly 2/3 of them about this issue. So went back and forth. Hey, can I make some changes? No, that's not working. So at the very beginning, I said that one major reason why I could not use it, because there's a face here. So that face may be somebody's face. We don't know. So AI used a great amount of data, including like maybe one sample with this face. So it may not be an actual case. It may be a combination of multiple faces, but nobody knows. They said that we don't have ability to judge whether that will cause any copyright issue. So we cannot give you the approval for using it. So I say, hey, you cannot use AI. Now let's use my own face. I have the copyright for my own face, right? I confirm that. Yes, you have a copyright for your own face. To be safe, I modified my own face a little bit so that I will not violate any copyright against myself. So I used the second one. I replaced this with my own face. And I shared with them. They said, no, our face is just like one major concern, but you still have many other concerns. So eventually, I used something like this. I kind of don't use this anymore. I convert everything into very small numbers with different colors, which still, have some traits similar to this one, but now it's totally different. They said, oh, finally, if you use something like this, it's okay. And also, you see that in my slides, I used my face a lot. That's not because of arrogance. It's just because that I don't want any issue. So in the AI world, we need to be very careful. And we know that in traditional academic practices, for example, publications, whatever you want to use, that's what's created by somebody else. You need to give the credit to that people, right? But now the problem with the AI world is that we don't know who created that because it's just a small part of a very big chunk of data and nobody knows. And it's a black box in it. So when you are using AI for doing things, I think we need to be very, very careful with this. So I want to talk about Kant first. Next is what we can do. I don't want to cover a lot of things, but just want to give you guys two simple examples to show you how powerful AI is these days. Possibly you guys know that much better than me if you have tried a lot of things yourself. But in case you haven't tried it, first thing that I want to talk about is something called personal knowledge base using technique called RAG. So we know that we can use large language models, right? You go to the ChatGPT website, you put in question there, you can get very good answers. Actually, now ChatGPT is really good. It's not for daily questions and ask ChatGPT a very specific research question. I think I'm a domain expert in that area, but ChatGPT gives answers that's much better than what I can provide. So that surprised me. But of course, if I take a closer look, I will find minor glitches in it. And if I keep pushing like AI said that you're wrong there, and then ChatGPT can give me a better answer, say, yeah, I'll overlook something and here's something else. So we need to be very careful when we're using this. But one problem with the use of ChatGPT is that it can only come up with the answer based on information from the internet, right? For example, I want to use ChatGPT to do my own design for this specific case. I have some material, some cooking materials for that job. How to do that? Now we can use the personal-based thing. For example, here's just one example I did. I used DeepSeek. And what I did is that I uploaded my own resume. So my resume has some very private information in it, and that's not available online. So I asked DeepSeek with my personal database, and then DeepSeek can give me the answer. So I asked him, oh, hey, what conference did I attend recently? Obviously, that cannot be found online, and DeepSeek can give me a very good answer based on my resume. That's just one tool. Another tool, actually, I just created this morning. We have many AI coding tools. This is one of them called Cursor. I'm not sure if you guys used it before. Let's show how to use it. For example, I say, please create a web page similar to a template that I want to attach. That template is actually the department website. So I put in my question here. I want to say, hey, give us the same graphical user interface. And then I attached a screenshot of our department website. So you can see that at the very beginning here, there's nothing here. There are no files here. There's nothing here. And then I click it. So you can see that now tool is trying to generate the code for me. So I didn't do anything. I just put in one question, one request, one query here. And you can see that some contents were being generated automatically. So we see a CSS file, but AI is not perfect. It says that generated file, but there's no HTML file. That's the major web file. So I say that, hey, please generate the web page as well. So now there's only one CSS file for controlling the style of web page, but there's no major file. So I wait a little bit, and I can see that a new HTML file will be generated here. You can see they call it index.html. So it's done within seconds. And then we can take a look by clicking on it, and we can see a page that it was just created within a very short amount of time. So this is what it looks like. So you can see how powerful it is. It can save us a lot of effort in tedious work. So this is actually my last slide. I just want to use another thing. It's very similar. Here I want to give myself like a British accent.
University of Virginia, absolutely phenomenal place. Thomas Jefferson's brainchild, and you can feel the history and innovation in the air. Academically rigorous, insanely beautiful campus, and a culture that fosters real problem solving. Go Who's!
So this is actually what I want to share about AI. Hopefully it can be useful in some way. And if you guys have more questions about AI or any other things, please feel free to stop by.
I think I'm falling for you.